Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 1 to infinity, 1 over 2x plus 1 cubed dx. This is an improper integral, which you can see by noticing the infinity in the limit of integration there. So we have to use the definition of an improper integral. The limit as b goes to infinity, the integral from 1 to b, 1 over 2x plus 1 cubed dx. This integral now is an integral that the fundamental theorem of calculus would apply to. So let's go over here on the side and evaluate it. The integral from 1 to b, 1 over 2x plus 1 cubed dx. We need to do a small substitution, so let's let u be equal to 2x plus 1. du is equal to 2 dx. So we need to multiply by 2 inside the integral, and we can divide by 2 outside so that we don't change our integral. Then this becomes 1/2 the integral from our new limits of integration, 1 over u cubed du. 1 over u cubed is the same as u to the negative 3. And remember, to integrate that, you add 1 to that power, so it'll be u to the negative 2. You divide by that same number, negative 2. And since it's a definite integral, you must evaluate on the limits of integration. We know what u is. Also, we could bring out that negative 2 in the bottom. So negative 1/4, and then u is equal to 2x plus 1. And the negative 2 as the exponent, the negative will drop the factor of u squared into the denominator, so it becomes 2x plus 1 squared in the denominator. Now we're back to x's, so we may evaluate on our original limits of integration, which were 1 to b. So this is our definite integral. So it goes over here and waits for the limit to be evaluated. So it's negative 1 over 4, 2x plus 1 squared, evaluated from 1 to b. First, we substitute in b, the upper limit of integration. Two b plus 1 cubed squared, minus, then we substitute in the lower limit of integration, which is 1 here, squared. Now we can simplify some, and then try to take that limit. So this first term just remains as it is. Nothing to do to simplify that. This term, the two negatives will make a positive. 2 times 1 is 2, plus 1 is 3. 3 squared is 9. 9 times 4 is 36. Okay. Now we can evaluate our limit. Notice that b is getting closer to infinity, so b is getting larger and larger and larger. As b gets bigger, 2 times b gets bigger, 2b plus 1 gets bigger. If you take a big number and square it, it gets really big. Multiply by 4, that's even bigger. So negative 1 divided by a very large number is very small. So as the denominator gets larger and larger, the whole fraction gets smaller and smaller, and so it's going to go to 0. plus, and of course the limit of 1/36 is just 1/36. It's a constant, so the limit doesn't change it. So in this case, we find that our definite integral that we started with, namely the integral from 1 to infinity, 1 over 2x plus 1 cubed dx, converges the integral from 1 to infinity, 1 over 2x plus 1 cubed dx converges and is equal to 1 divided by 36.